Okay, I'm so sorry, but I got interrupted in the last video with the phone call. I didn't know how to restart it. So the section where you're supposed to be doing them on your own anyway is now going to be a separate video. So these should all be a check. You should have done these first and then do them, then check and do them and check in this video. So we see these are the left or below. These are the right and above of the number 1. This is a horizontal line, so as I'm approaching 1, I'm going to remain -3. On this one, as I'm approaching +1 from the right or from above, the numbers are getting smaller, I'm becoming -2 for a y value. These are not equal. Notice the left and the right are both numbers, real numbers, and they're not equal to each other, so this means this is a jump. The limit does not exist because the left limit and the right limit must match. There is a function value, and it has absolutely nothing to do with the problem. Now moving on to problem 14. In problem 14, we see that we have a left side and we have a right side. These numbers are below 1. These are x values above 1. We see that there is indeed a point missing. There's no other point listed. As my x's are approaching 1, my y's are getting smaller and approaching a value of -2. As my x's are approaching 1 from the right, my y values are getting smaller and approaching -2. These two are equal, so that tells me that my limit exists and is -2. But I notice that there is absolutely no value at this point and nowhere else along the vertical line, so this is undefined. And this is the definition of a point missing, which is a point discontinuity. A point can only be called missing if the limit exists. Notice the connection is to the same point that's missing, and we call it a hole. Problem 15 is pretty much like problem 14. It's the same exact problem, in fact, except I now have an ordered pair. So again, as my x's approach from the left or below, my y's are getting smaller and approaching -2. And as my x's are getting from above or from the right are getting smaller, my y's are also getting smaller, approaching -2. These two are both real numbers and equal, so I do have what's called a limit. Both sides are approaching the same y value, but the actual y value is up here. And again, don't get fooled. This is the ordered pair 1, 0, so the y value is 0. Again, we see that when the limit exists, we have to have a limit. These two have to have the same value, but it doesn't match the function value. This means a point is missing, which is called a point discontinuity or a hole. Problem 16. I'm giving you another one that has a vertical asymptote. Notice there is no ordered pair on the asymptote. The below or left side is here. The above or right side is here. As my x's approach 0 from below or the left, my y's are heading up heavenward, so they're going towards positive infinity. No, that's not a real number. Again, this means I'm D and E, but this is the direction I'm heading. That's what the symbol means. It implies D and E. On this side, I am coming down, and I'm heading towards Satan, negative infinity. What does negative infinity mean in calculus? It means you are D and E, and this is the direction you're going. They are going in opposite directions. Hence, we say our limit is D and E. There is no function value. It's undefined. This is called infinite. It's called vertical asymptote in AP. In most books, as always, as in college, they will probably refer to it as an unbounded type of discontinuity. Problem 17. I'm back to another one. We really meant to put an ordered pair on the asymptote. I'm so sorry we didn't. But hey, such is life. What do we see that's happening? Here's the left side. Here's the right side. Yes, there's a horizontal asymptote there. We don't care. Just the vertical one here. I'm heading towards heaven. The other side heading towards heaven. Yes, these both say we're D and E, but they are the same kind of infinity, so I'm allowed to write positive infinity as my conclusion rather than D and E. I only write D and E with infinities when these two don't match. So this means D and E, undefined, because we did not put the ordered pair on like intended. Therefore, what do we know? In AP, it might be called an infinite discontinuity, a vertical asymptote. But again, in our textbook and in college, it will be called unbounded. The last problem is another one that for this worksheet only, you cannot do it unless you're told otherwise. We're going to assume that if we don't see an open circle, that's a closed circle right there at 0, 0. So these are the below side. This is the above side. As my x's approach from the left, they're getting closer and closer to 0. But my y's are getting smaller and they're approaching 0. From the right side, as the x's are getting smaller and smaller, approaching from the right. From above, my y's are getting smaller, they're 0. So these are equal, the limit exists, it's 0, the function value is 0. When these two are equal, we say that the function is continuous. So these were the checks. Sorry that it didn't make it all in one video. My apologies.